Okay. No, trust me. These two are super easy. Okay. All this says is tell me whether it's growth or decay. You can start it again. Tell me whether it's growth or decay, and then graph it. That's all it says. Tell me whether it's growth or decay and graph it. Okay. Tell me if it's growth or decay and graph it. Here we go. How do you know whether it's growth or decay?
It's over 1 or less than 1.
If it's less than 1, it's what? Decay. If the base value, you might want to write that in your notes. If the base value is less than 1, it's decay. If the base value is more than 1, it's what? Growth. What if it was 1.3? 1.03? It's still growth. Okay? If it's greater than 1, it's growth. If it's less than 1, it's what? Decay. That's all there is to it on an exponential function.
So both of those are
So which one is this?
growth.
Nope.
Oh no, it's decay.
This is decay.
I was thinking it was
Because 6/7 is less than what?
1.
1. So that's decay. This is what?
Growth.
Growth. Okay, that's it.
Yeah, I did. No, I read it 7/6.
It's 6/7.
I know, but I flipped it.
Apparently all you guys are just like flipping it. I don't know why you're flipping it. It should be that. All right. Okay, so let's graph these. Let's graph this one first. Now, if you have a graphing calculator, all you got to do is graph it and hit trace and graph a few points, right? If you don't have a graphing calculator, put 0 in. That's going to give you 1. And all you got to do is plug in 0 and put it as an exponent, 2 raised to the 0. Then just do 2 raised to the first. That's going to be 2. Then hit 2 raised to the second. That's going to be 4. And then 2 raised to the third. That's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And so it's going to go like this.
So we're gonna have to graph it on the test.
And that's what you're going to have to do. Yeah, you're going to have to graph it. So, and it'll come down like that. By the way, it never crosses what? The x-axis. It gets closer to it, but it never really crosses. Because remember, if I did negative values, it would be 1/2, 1/8, 1/16, 1/124. It's getting smaller and smaller, but it's never getting to what? Exactly 0. You with me on that? So you can go backwards, but I usually just go forward. So remember, this point is 1, 2. How did I get 1, 2? Plugged in 1, got 2. 2, 4. How did I get that? 2 squared is 4. 2 cubed is what? 3, 8. That's how I got that. And this is 0, 1. Okay? And that's kind of some points I put on my graph. That's that one. Okay, how about the other one? You graph it the same way, but it's going to be kind of weird.
Yeah.
It's going to be kind of hokey, right?
And upside down.
This one's still going to come through at 1.
Yeah.
But what's it going to be at 1? Point something,
86.
6/7, whatever that is.
86.
What's it going to be at 7? No.
Point
No, 6.
0.40.
Okay, so 1, 2, 3, 4, 5, 6. You're going to get 0.4. So this is 6.4. Okay, that isn't helping me much, is it? You really need to go into what direction?
Up, so
Go -6. How come I picked -6, by the way?
Because it's
Because that's going to flip it, actually. So go to -6. 1, 2, 3, 4,
2.52.
5, 6. What is it?
2.5.
2?
2.52.
0.52. So 2.52, you can hit half of that, which is about 3. Hit 3.
1.6. So
1.6. So it's gently going. Is this much of a curve?
no.
No, this is a much more gentle curve coming down. And that makes sense because it's that much of a decay. No, it's a small amount of decay. Right? It's going down just a little every single time. Okay? That was numbers
16
what?
and 17.
16 and 17, okay? 14 and 15. Find the inverse and graph the inverse. And they're both linear, so these are incredibly easy again, because I did linear equations. So find the inverse, graph the inverse. Everybody got it? And they're just linear. So if I have f of x equals, I'll do the hard one on here. Let's say it was 5/4 x minus 9/2. Let's say it was like that. Okay? How would I find the inverse? What does inverse mean? Opposite. So I'm going to switch the x and the what? Y. So think of this as not being f of x, but being what? Y. Then switch them. So now I'm doing inverse. So I'm doing x equals 5 over 4. And I always, oh, hello, McFly. All right, 5 over 4 y inverse. I always just put a little dash there, reminding me that I'm actually trying to find the what? Inverse. So that just tells me, hey, I'm doing the inverse. I've changed my x and what? Y. And then minus 9/2. That's it. Now I want to get the y by itself. How do I do that? I can add 9/2, but I don't like fractions. Do you guys like fractions? I hate them. I'm going to times everything by 4. Why? Gets rid of the fractions. So I'm going to times everything by 4. 4 times x, 4x. 4's go away, 5y inverse. 2 is into 4 how many times? 2. 2 times 9 is negative 18. So I get rid of the fractions right off the bat. Then I solve it. It just makes it easier. You could do all the subtracting of fractions and do fractions all the way through, but then you'll have to find common denominators and gets yucky. So I'm going to add 18. I'm just getting the y inverse by itself. 4x plus 18 equals 5y inverse. Divide by what? 5. That's my answer. Okay. Then it says do what? Find the inverse of the function. Then graph the function and its inverse. Graph the function and its inverse. Now I'm going to show you something that's important that I'm going to be looking for on these graphs. Okay? So, first of all, I've got to do 18 fifths. That's my y-intercept. What's 18 fifths? 3.6, right? So I'm going to go up what? 3.6. That's where I'm going to start. How far up and over will I go? Up what? 4 over 5. See, watch. Both of these are being divided by 5. 4 fifths x plus 3.6. So what's my y-intercept? 3.6. What's my slope? 4 over what? 5. So I'm going to go up 4. From here, 1, 2, 3, 4, over 5. 1, 2, 3, 4, 5. There's my graph. There's my line. There we go. Okay. So there's what that one looks like. And then my other graph should start where? Where's my original going to start? At negative what? 9 seconds. Where's that at? 4.5. It's going to go up what? 5 and over 4. It's going to go up like this. Where should these cross at? This is what I'm looking for. Where should those cross at? Every inverse, by the way, every linear inverse, I should say, should always cross along this dotted line. Where the x and y are what?
The same.
They equal, the same, yeah. So the dotted line where all x's equal all y's, which is that dotted line I just drew, 1, 1, 2, 2, 3, 3, 4, 4, are you with me? All that line, that's where the two inverse lines should always what? Cross. Now it's going to be clear up there, I don't know where it is, but
It's 18.
they'll cross up there, and it will be on this line. 18, 18? Yeah, 18, 18 is where they'll cross. Okay, if I go out 18 and up 18, they'll cross there. Which makes sense. It's always got to be where the x and the y are what? Equal. That's the only place it would cross. So I'm kind of looking for that as you graph inverses. If your inverses don't cross on that dotted line, did you get the graph right? No. Is the graph really that hard though, honestly? No, because you're just graphing a line. Both of these are lines, okay? That are, find the inverse, switch the x and y, solve for y inverse. Graph the inverse and the original. Notice I graphed both. I graphed this one and this one. I have to graph both, okay? All right, that was numbers what?
14
14
and
and
15.
15. Okay, the rest of them are seriously, mostly off of Chart of Destiny. Okay, Chart of Destiny. So here we go.
12 and 13 on.
Oh, yeah, we do that for the first high school, so they don't. He said if you can do every class chart by the end of the year, then you'll be good.
Yeah, I definitely do not have the time.
How was sleeping?
Oh, that.
Okay. Write your answers using only positive exponents, it says on the test. Write your answers using only positive exponents on the test. Okay? What do I do?
First times. Add your, or do your exponents. Get it out of the parentheses.
What numbers are the first one test?
12 and 14.
This is 11 through 13.
Do you distribute the negative 3?
11 through 13. What do I do? Make sure you treat what? The coefficient different than the what? Than the exponent. Remember, there's no equality here. Don't treat them the same. Don't treat the coefficient the same as the what? Exponent. That's where you'll mess up. You've got to treat the coefficient and exponent differently. So when I take negative 5 raised to the negative third, what am I going to get? Well, first of all, you got to think of it as a negative times a negative times a negative, which is a negative. So this is going to be negative for sure. Now I've got 5 to the negative third. Does the negative exponent make anything negative? No. This is negative, but the exponent didn't make anything negative. 5 to the negative third, what does it do to it?
Makes it small.
Flips it. So make sure you write that in your notes. A negative exponent flips it top to bottom to make positive. Flips it top bottom to make positive. So this is really negative 1 over 125. How did I get 125? 5 to the third. 5 times 5 times 5. So 5 to the negative third is 5 times 5 times 5, but on the what? Bottom. It doesn't make it negative. It changes it from top to what? Bottom. Everybody got with me so far? I've only done the coefficient. I did negative 5 raised to the negative third. By the way, you could do that on your calculator, but it'll give you a decimal.
But then you can press math.
But then you can hit math, fraction, and it'll give you that. Okay? But it will give you a decimal when you originally do it. Because but I can just do it in my head, thinking about 5 to the third. 5 times 5 times 5, 125. Okay? All right. How about the t's, though? What are you going to do with the exponents? You multiply the exponents. So t to the
15.
negative 15th, but I need to make it positive, so I put it on the what?
Bottom.
Bottom. T to the 15th on the bottom. So it's really t to the negative 15th, but to change a negative exponent to a positive, I've got to flip it top to bottom. What's a negative times a negative, though?
Positive.
It's a positive, so u is going to be to the what? Where?
Top.
Top 6. Right. U to the 6th. So I really don't need that one. I can leave it just like that, and that's my answer. Okay? There's 3 of those. Everybody got it?
Yep.
Okay.
So, we're doing 9 and 10 now.
This is 9 and 10. These are super easy. You can just punch them into your calculator if you want. Make sure you use a parenthesis raised to the 1/3. Okay? That's the only way you miss it. If you do this little raise to the thing, make sure you put a parenthesis around the 1/3.
It's 9, isn't it?
Yeah. Now, what else could you do? This is really saying take the cubed root of 720 what? 9. You can do that on your calculator. You can factor tree that once it's written that way. And you'll end up with what? I don't know what it is. Is it 7 or 9 or what is it?
9.
9? Okay. Which means, by the way, that 9 times 9 times 9 is what? 729. Okay, isn't it? 3 9s. If I factor treed that down, you see what I mean? That's what we would do in the old days. But really, could you just punch into your calculator?
Yes.
Yeah, so those are easy. You just punch them into your calculator.
That's just those two, 9
Yep.
and 10.
Then you got to do a tough root. Say we have the 6th root of negative 64.
It goes into our calculator.
Can you? I don't know. Punch it in and see what it says.
Yeah, math. If you go.
There's a math and there's an X root key, but I don't know if it's going to do this one.
I don't think
This one isn't real good because it's an even what? Root. But you can still do it on your calculator. You just have to remember that it's going to be a what? It's going to be an I. How come we know it's going to be an I? Even root of a negative. Even root of a negative is going to be a what? I. But I'm going to do the 6th root of 64. I can do that on my calculator. Go 6, X root key, which is under math on your graphing calculators. X root of 64. You can do that. And it gives you what? 2i. Everybody has them. We can all see. 2. You got 2. Okay, that was funny. Yeah, just wait. Calm down. Get yourself under control. All right. By the way, if it's an odd root, does it come out as an I? No, it'll still be a what? Negative. So you can take an odd root of a negative, it'll just come out as a what? Negative. Write that in your notes, because you might get an odd or an even, depending on which test you get.
How did you get 2i? You just.
So the I is this.
Well, I'm
What?
not confused about the I. I'm confused how you got 2.
Oh, I did the 6th root of 64.
But that's giving me.
Do it.
It gave me like 3 times 2 to the 1 plus 6 over x.
I have no idea what the hell you're doing.
Uh,
6th root of 64 gives you
I see why.
2.
Never mind. Yeah, never
I
mind.
don't. And how come I know it gives me 2, by the way? I'm just really fast. Watch. I'm doing a factor tree, but I'm doing it in my head. Because I'm just making these problems up in my head. How many 2s are there?
6.
6. That's how come I know it's 2. That's what I mean, I do it really fast in my head, but that's what I'm doing. I'm just factor treeing 64 really quick. So it's 2i. Because I have 2 i's. You have 2 i's. We're all good. How did I get that? I actually think of this as what? Factor tree. -1, but that -1 will come out as a what? I. Everybody with me? What is the left? Well, a 64. 64 factor trees. I've got to have 6 of the same factor. How many 2's are there? There's 6. So that's 2i. Now on your calculator, it's doing that, right? When you hit 6th root of 64, it's doing that. It's just doing it really fast, right? But yeah, it's just doing a factor tree. That's all it's doing. Okay? All right, so that is 8. Let me see if it's also 7. I'm not looking at 7 right now. That's 7 and 8. Okay, so that's 7 and 8. Okay? All right. Number 6. This is a story problem. And it's a step function.
Oh, those are easy.
These are pretty easy. So they're that piecewise function stuff. Okay, so this is what it says. Okay, so you have a health club membership. Okay. The club charges, let's say, they have a special going. They're going to charge you $30 for the first month and $40 every month after that. So $30 for the first month and $40 every month after that. Okay? $30 for the first month, $40 for every month after that. Okay? Your graph looks like this. Total cost is your y-axis. Your x-axis is months. How would your graph look? And what is your f of x equation for the first 4 months? What's your f of x equation for the first 4 months? Okay.
Would it be like 1?
That's what it's asking. Okay? Or, sorry, T of C equation for the first 4 months. Your T of C equation for the first 4 months. Okay? So, what's the very first month going to be?
30.
From day 0 to day 1. How much are you going to pay?
30.
$30. That's from day what? 0 to day 1. Or month what? 1. If I quit going to the gym, how much would I owe?
$30.
If I do it exactly at 1 month, I'm going to owe what? I'm gonna owe $30. So from month one, oh, sorry, one, there we go, sorry. I'm gonna owe that $30. What's going to happen from day 1 to day 2? Or sorry, month 1 to month 2. Sorry, I keep saying day. Month 1 to month 2. How much will I owe?
40.
Total.
Oh, 60.
Oh, 70.
70. How did you get 70?
30 plus 40.
I already had the 30 that I had paid them, but I'm paying another what? 40. It's $40 every month after this. Everybody with me on that? $30 for the first month, $40 every month after. Okay? How much total? Remember, this is total cost. How much total will I? Oh, by the way, this is not an equal to. That's just a less than, isn't it?
Yeah.
Yeah, because once I go 1 day over, 1 minute over the first month, am I going to owe the other 40? Yes. You with me? So this is going to go from 2 less than x to what? 3 to month 3. And how much will I owe? If I go 1 day over 2 months, what am I going to owe? I'm going to owe 110 because I'm adding another what? 40. And then the last month, 100 and what? 150. That's for 3 to 4. Okay? Now, it's going to have that. This is my function. These are my parameters. And it wants me to graph it. How do I graph it? Well, I probably want to go by what? Maybe
Tens.
20s. Let's go 20, 40, 60, 80, 100, 120, 140, 160, 180, just like that. Okay, here we go. Month 1, from 0 to 1. How much am I going to owe? $30. So out here to month 1, I owe $30. I guess I don't owe anything if I don't go, huh? So that should be a 0 with a not equal to, right? Because I don't owe anything if I don't go. So if I never show up at the gym, then I don't have to owe any money. So yeah, that's a 0. So I guess that one is open circle. Then what happens at 70? I'm going to have an open circle on this end and then a what?
Closed.
Close to the second month. And then go up to 110. Open circle, closed. That's going to be in my third month. And then from my third month, 150. Open circle, closed to my fourth month. Everybody got it? And that would keep going in that fashion, right, if I kept going. But it just said for the first what? 4 months. Okay? So if you'll notice on the test, this is a multiple choice one.
Oh, sweet.
And it has a graph. Make sure you pay attention to what the graph is measuring, right? Like how it's measuring it. Is it going by 20s? Is it going by, you know what I mean? Make sure you know the parameters of that graph. And then make sure that you have the right equation to match the graph. So the equations are above, the graphs are below. But you're really just having an equation and a graph. But the equations are above. Everybody got it? That's number what? 6. It's a little story problem, but it's not very hard. Okay, then we're on number what? 5 and 4. They are just graphing linear step functions. You want me to do one of those?
Yeah.
Okay. Or sorry, piecewise functions. So you just have f of x equals, say, negative x plus 5 and 2x minus 3 for x is less than or equal to, let's say, negative 2, and x is greater than 2. Negative 2, sorry. So something like this, right? Can you do it? Fairly easy. What's the key point you want to plug into both equations?
Negative 2.
Negative 2. Always plug in the what? You might want to write this in your notes. Always plug in the what? Parameter to both equations. That's the key, because that's really your starting point. So if I plug in negative 2 here, what's a negative times a negative? Positive. 2 plus 5 is 1, 2, 3, 4, 5, 6, 7. Negative 2, 7. Should I close circle or open circle this one? Equal to, so it's closed. Okay. Now, by the way, from there I can follow the slope. What should I do?
Why did
Go
you
down 1 and what?
Why'd
what?
you go up 7?
I plugged in what?
Oh,
Always plug in the parameter. That's what I said to write in your notes, right? Plug in the parameter for your starting point. Don't start on the y-axis. That's the only thing that throws kids off here. Yeah, I have a lot of kids who start on the y-axis. Why don't you want to start on the y-axis? Well, it depends on whether you're going left or what? Right. Now this one should go where? Can it go right? No, it has to be less than. So I can't go to the right. So I don't want to go down one and over to the right one. I want to go up one and to the what? Left one. And up another one and to the what? Left one. This one's going to go out this way. Okay? Everybody with me on that? Because it can't go to the what? Can't go to the right. Has to be less than what? -2. So I can't start at 5. If I start at 5, it's not part of where my graph can exist. My graph can only exist if it's less than or equal to what? -2. You with me on that? So that's why I have to go up 1 and over to the left 2. 1, -1. 1, -1. And I can keep going that way all I want, but that's where it's going to go. Everybody got it? Now, where should I start on the second graph?
-7.
Plug in what? -2. -2 times 2 is?
-4.
-4 minus 3 is?
-7.
-7. 1, 2, 3, 4, 5, 6, 7. -2, -7. Open circle or closed? Open, because it doesn't actually touch there. And from there I can follow the slope, going up 2 and to the right 1. Do I want to go right? That tells me I want to go what?
Left.
Right. Doesn't it tell me I want to go right? Yeah. I want to go greater than -2. So yeah, I want to go up 2 and to the right 1. Up 2 over 1. Up 2 over 1. Boom. This one's a little steeper. Going to the right. That's it. That's my whole graph. Okay. So that's all there is. And that's 4 and what? 5. 1, 2, and 3. 1, 2, and 3 graphs the following. It's just graphing absolute values. I'm going to do like the hardest one, realize that they're easier, but they all follow the same principle. What's the key equation you want to use? What is the key equation you want to use for absolute values when you're graphing? Plus or minus what? A, absolute value, x minus h, and absolute value, plus what? K. HK will be your what? Vertex, and A is your scale factor. Okay? I'm going to do the easiest one, or I'm going to do the hardest one. Remember, like number 1 is only going to have this part of it.
Yeah.
Number 2 is going to leave out the H but have the plus on the outside. Number 3 is going to have the whole thing. So I'm going to do one like number 3. You with me? But really there's 3 graphs. They're all absolute values, but they're going to leave out different elements on the other ones. I'm going to do the one with all the elements in it. Got it? So I'm doing the hardest one. So let's say f of x equaled -3 absolute value of x minus, let's see if there's any fractions or decimals. There's not. X minus, say, 7. Well, let's make that smaller. X minus 1 plus 7. That'll be good. Okay. Where do I want to start?
Your vertex.
At the vertex. What is the vertex? Don't forget to change the sign of what's
1,
inside of there.
7.
So I've got to go to 1 on the x and up what?
7.
7. 1, 2, 3, 4, 5, 6, 7. That's the vertex. Now where do I go? Normally, what would you do? If there's nothing in front, I would go over 1, up what? 1. Both directions. Over 2, up 2. Over 3, up 3. It ends up being a V, right? This will end up being a V, but you won't do it that exact same way because I have to multiply those values by what? -3. In other words, I go left and right 1 and down what?
-3.
Down 3. 1, 1, 2, 3. 1, 1, 2, 3. Okay. Now I'm going to go left 2 and down how many?
6.
Normally 2, but 2 times -3 is 6. So I'm going to go down 6. I'm going to go right 2 and down what? 6. Sorry, I think I'm out of control here a little bit. That should have been right here. Sorry about that. Okay. And then this goes straight down through there. This goes straight down through there. And that's what it looks like. Okay. So that's all there is to those. That's the whole test.
This is easy.
Yep, stop.